Have you ever stopped to think about how much paper shapes your daily life? From the book you flip through on a lazy Sunday morning, to the receipt you tuck into your wallet, to the cardboard box protecting your online order, paper quietly surrounds us, keeping society moving. It's one of those everyday materials we take for granted, yet without it, the world would feel incomplete. Long before smartphones and laptops, paper was the backbone of communication, education, and culture. And even in a digital age, it continues to thrive, not only in books and newspapers, but in packaging, hygiene products like tissues and toilet paper, and the countless creative projects where paper is the canvas for imagination. The story of how a tree transforms into the sheets, rolls, and cartons that pass through our hands every day is nothing short of fascinating, and today we're diving deep into the remarkable journey of paper production in the United States, where history, innovation, and sustainability all come together. The roots of America's paper industry stretch back to 1690, when William Rittenhouse established the very first paper mill in Germantown, Pennsylvania. Before that, the colonies depended heavily on expensive imported paper, but this moment marked a turning point. Suddenly, communities could produce their own supply, fueling the growing hunger for knowledge, communication, and record-keeping. By the 18th century, the demand for paper skyrocketed as newspapers, pamphlets, and revolutionary writings circulated widely, carrying the ideas that helped ignite the American Revolution. Without the mass production of pamphlets and broadsheets, the spread of independence-driven ideas would have been far slower. Paper became more than a medium, it became a tool of freedom. As the 19th century dawned, the industry underwent dramatic change. Instead of relying solely on rags, paper makers began using wood pulp, which opened the door to mass production on an unprecedented scale. Mechanized paper-making machines revolutionized the process, slashing costs and making books, newspapers, and packaging affordable for ordinary Americans. The rise of advertising and consumer goods fueled further demand, cementing the U.S. as a leader in global paper production. What had once been labor-intensive and artisanal was now a roaring industrial force. By the late 1800s, paper mills thrived across the country, and the nation's appetite for reading, printing, and packaging seemed insatiable. Fast forward to today, and the paper industry in the U.S. has not only maintained its importance, but has also embraced modern sustainability practices. Recycling and eco-friendly production methods are at the heart of this transformation, ensuring that while paper remains essential, it doesn't come at the cost of the environment. Every sheet of notebook paper or cardboard box now carries a deeper story of balance between human needs and ecological responsibility. But how exactly does a towering pine tree from Oregon or Georgia become the smooth, crisp sheet in your printer? It all begins in America's vast forests, where sustainable harvesting ensures that every tree felled is part of a carefully managed cycle. In states like Oregon, Alabama, and Georgia, pine and hardwood trees are cultivated specifically for papermaking. Workers cut and transport the logs to massive mills where the transformation begins. The first step is cleaning, removing dirt, branches, and bark. At the mill, giant debarking machines strip away the outer bark, exposing the clean wood beneath. The logs then enter powerful chippers, which slice them into small uniform wood chips, perfectly sized for the next stage of pulping. This is where the real magic happens. Those humble chips are turned into pulp, the raw material of paper. Two main methods dominate: mechanical pulping and chemical pulping. In mechanical pulping, grinders shred the wood chips into fibers. It's fast and efficient, but the resulting pulp still contains a lot of lignin, the glue-like substance that binds wood fibers together. Chemical pulping, on the other hand, uses solutions like sodium hydroxide to break down and remove lignin, freeing the cellulose fibers that give paper its strength and flexibility. This method produces higher quality paper, especially for writing and printing. Whichever path is chosen, the end result is a slurry of fibers that has little resemblance to the solid log it once was. Once pulping is complete, the mixture is carefully washed to strip away lingering lignin, dirt, and chemicals. If bright white paper is the goal, bleaching agents such as hydrogen peroxide or chlorine dioxide are introduced. Workers monitor the process closely, ensuring that the pulp reaches the right brightness and consistency without compromising quality. At this stage, the pulp is ready to be shaped into actual sheets of paper, and this is where the engineering side of papermaking truly shines. The pulp, now consisting of about 1% fiber and 99% water, flows onto a massive moving mesh screen known as a Fourdrinier machine. As the watery slurry spreads across the screen, gravity and suction work together to drain out the water, leaving behind an interconnected mat of fibers. Slowly, a fragile wet sheet begins to form, a ghostly preview of the finished product. This sheet travels through a series of rollers that press it tightly, squeezing out even more water and compacting the fibers together. These rollers also give the paper its first taste of strength and smoothness, preparing it for the drying process. From there, the paper moves through gigantic heated drying cylinders that evaporate the remaining moisture. This step is carefully controlled, because overdrying could make the paper brittle, while underdrying would leave it too weak. Once fully dried, the sheet is strong, crisp, and ready for finishing. To achieve the smooth, polished texture we expect from modern paper, it passes through a series of calendaring rollers that press and refine its surface. Depending on the paper's final use, it may also receive coatings that give it a glossy, matte, or water-resistant finish. Finally, it's wound into massive rolls or cut into sheets, then packaged and shipped to offices, schools, publishers, and factories across the nation. But the story doesn't end there. In today's eco-conscious world, the paper industry has embraced recycling on a huge scale. Used paper is collected, cleaned, and repulped, giving old notebooks, newspapers, and cardboard boxes a second life. This reduces the need for fresh wood and keeps tons of waste out of landfills. Mills also focus on saving water by cleaning and reusing it multiple times during production. Many facilities now rely on renewable energy sources such as biomass to power their machines, slashing their carbon footprint. These measures prove that even an ancient industry can adapt to modern sustainability goals. Interestingly, while paper remains a core part of daily life, not all paper products are what they seem. Take the US dollar bill for example. Despite its appearance, it isn't made from traditional paper at all. Instead, it's crafted from a special blend of 75% cotton and 25% linen, which gives it a distinctive feel and exceptional durability. This ensures that even as bills pass through countless wallets and cash registers, they remain intact far longer than ordinary paper would. It's a small but fascinating reminder that paper making is as much about chemistry and engineering as it is about cutting down trees. And just as paper has evolved, so too have related industries. Consider rubber bands, seemingly simple tools, yet essential in offices, homes, and factories across the U.S. Modern factories can produce over 12 million rubber bands in a single day, thanks to precise machines that cut and shape elastic with incredible accuracy. The history of the rubber band traces back to 1845, when English inventor Thomas Hancock patented the process of slicing vulcanized rubber into thin, elastic loops. Vulcanization itself, discovered by Charles Goodyear in 1839, revolutionized rubber's durability and elasticity. Since then, rubber bands have become indispensable worldwide, pairing perfectly with paper in binding stacks of documents, sealing packages, and organizing everyday life. Have you ever stopped to think about something as small and ordinary as a rubber band or a pair of disposable gloves? These simple items are so common in our daily lives that we rarely pause to wonder where they come from or how they're made. But behind these everyday essentials lies an incredible story of innovation, history, and modern manufacturing. Imagine the journey of raw rubber from a tree deep in a tropical plantation, traveling across oceans, entering factories filled with massive machines, and finally transforming into the tiny band that holds your mail together or the glove that protects your hands. It's a process that combines age-old discoveries with 21st-century engineering, and once you see how it all comes together, you'll never look at a rubber band or rubber glove the same way again. Every single day, millions of rubber bands roll off production lines around the world, ready to be shipped to schools, offices, warehouses, and homes. It may look like the simplest product imaginable, but the way it's made is far more fascinating than most people realize. It all begins with raw rubber, a material that comes from latex extracted from rubber trees or sometimes synthetic rubber produced in chemical plants. To make the raw rubber workable, it first needs to be softened, which generates heat and transforms the hard lumps of rubber into a pliable, dough-like material. Once softened, this rubber dough is rolled into wide, flat sheets using massive industrial rollers that look like giant rolling pins. These sheets are sliced into long strips, bundled together and carefully weighed so that each batch remains uniform. That consistency is crucial because the next step involves adding a cocktail of chemicals that will completely transform the rubber's properties. This is where vulcanization comes in, a process discovered by Charles Goodyear in the 19th century that revolutionized the way we use rubber. By mixing sulfur and other chemicals into the rubber and then heating it, manufacturers create strong chemical bonds within the material, turning it from sticky, fragile latex into something tough, elastic, and durable. Without vulcanization, rubber would melt in the heat, crack in the cold, and fall apart under stress. With it, we get a material that can bounce back, stretch thousands of times, and last for years. Inside the factory, workers and machines mix the sliced strips of rubber with sulfur and accelerators until the chemicals are evenly distributed. The rubber is then fed into an extrusion machine, where it's forced through a die that shapes it into long hollow tubes. To keep the tubes from collapsing in on themselves, talcum powder and air are pumped inside, giving them their cylindrical shape. Once extruded, these rubber tubes are cooled in a water trough to stabilize their form, then carefully slid onto aluminum poles which act as molds. These molds determine the diameter of the final rubber band and prepare the tubes for the high-heat vulcanization stage. The molds, complete with their rubber coverings, are placed into massive steam ovens, where heat and pressure transform the material into strong, elastic rubber that won't easily break or lose its shape. After vulcanization, compressed air is used to remove the rubber tubes from the poles, and they're rinsed clean of any talcum powder or chemical residue. At this point, the tubes are hung to dry, but before they can be cut into bands, they're lightly remoistened to restore flexibility. This makes them pliable enough to be sliced by high-speed rotary blades that cut the tubes into uniform rings. Each band is carefully sized to exact specifications, and some machines can cut up to 500,000 rubber bands per hour. That's why when you grab a bag of rubber bands from the store, every single one is nearly identical in size and shape. But the story doesn't end there. Quality control teams carefully inspect batches of bands, removing any defective ones, before packaging and preparing them for shipment. From that point, they travel to offices where they hold documents together, to warehouses where they secure packaging, to farms where they bundle produce, and even to homes where they help organize everything from electronics to kitchen supplies. Despite their small size, rubber bands play a surprisingly important role in daily life, and because of their global demand, the industry produces billions each year. However, this massive production also raises concerns. Like many other rubber products, manufacturing rubber bands can have environmental consequences if waste, chemicals, and energy use aren't managed responsibly. That's why many modern factories now rely on renewable natural rubber sources, recycle defective products, and develop energy-efficient production lines. Consumers, too, can do their part by reusing rubber bands instead of tossing them after a single use, which helps reduce waste and environmental impact. Now, if rubber bands amazed you, wait until you see how something even more essential is made: rubber gloves. These protective items are everywhere. In hospitals, food processing plants, factories, beauty salons, and even in our kitchens. They keep hands safe from chemicals, bacteria, and dirt, and yet few people have seen the meticulous process that turns raw latex into the stretchy, skin-tight gloves we all depend on. The story of rubber gloves actually begins in the late 1800s when Dr. William Stewart Halstead, an American surgeon, introduced them to protect doctors and nurses during operations. His idea transformed medicine forever, and today billions of gloves are produced every year for industries around the globe. The journey starts in rubber plantations, where skilled farmers tap rubber trees by making small incisions in the bark. From these cuts flows a milky white sap called latex, which drips into small cups and is later collected in large quantities. This latex is transported to factories, where it undergoes a filtration process to remove impurities and is then mixed with stabilizers and chemicals to improve elasticity and durability. Meanwhile, thousands of ceramic or metal molds shaped like human hands are prepared on automated assembly lines. These molds are carefully cleaned and dipped in a special solution that ensures the latex will coat them smoothly without bubbles or defects. When the molds are ready, they're slowly dipped into vats of liquid latex, much like dipping a hand into a bucket of paint. As they're lifted out, a thin layer of latex clings to the molds, forming the first layer of the glove. Depending on the thickness required, the molds may be dipped multiple times, with partial drying between each dip to lock in the layers. Once the correct thickness is achieved, the coated molds are moved into heating chambers, where vulcanization once again works its magic. Heat strengthens the latex, making it elastic and tear-resistant, while also locking it into the shape of a glove. After vulcanization, the gloves are carefully removed from the molds using machines equipped with compressed air and soft brushes. This step requires precision because gloves must remain intact without tearing. Quality control teams then test the gloves by inflating them to check for leaks or stretching them to ensure flexibility. Any that fail the tests are discarded or recycled, while the rest are sorted by size, packaged, and shipped worldwide. Just like rubber bands, rubber gloves also face environmental challenges. With billions of disposable gloves used every year, waste management becomes a major issue. Traditional production methods also generate chemical byproducts, and large-scale rubber plantations can contribute to deforestation if not managed sustainably. Thankfully, Many companies are now working to create eco-friendlier gloves by developing biodegradable materials, recycling used gloves, and reducing harmful emissions from factories. These innovations not only make production safer for the planet but also give us peace of mind knowing that the items we use daily are becoming more sustainable. When you stop to think about it, the journey of rubber, from a tree trunk in Asia or Africa to a rubber band in your desk drawer or a glove in your kitchen, is truly incredible. It's a story of science, history, and engineering all rolled into one. Something as simple as a tiny elastic loop or a disposable glove embodies centuries of discovery, global trade, and technological progress. The next time you stretch a rubber band around a bundle of papers or slip on a glove to protect your hands, remember the incredible journey behind it. From the tapping of latex trees to the whir of factory machines, every stage is part of a process that touches millions of lives worldwide. So, what do you think? Were you surprised by the journey of rubber products? And do you have creative ways of reusing rubber bands or reducing glove waste in your daily life? Share your thoughts in the comments below, and if you enjoyed exploring the hidden world of rubber manufacturing, don't forget to like this video and subscribe for more fascinating stories about how the everyday items around us are made.